So welcome to part 3 of the previous year questions for the year 2023. Today we will see few more questions. In the last 2 sessions we already covered 4 questions. So 4 questions we had already covered. Question number 5. What is question? Fx is equal to fx is equal to 2 to the power 2x upon 2 to the power 2x plus 2. This is given function fx. Then what we need to find is f of 1 by 223 to this. We need to find sum of these terms plus 2 upon and continue till f of 2022 upon. We need to find this sum, right? Now we have fx, so we will rewrite it. So if you look at it directly, if you put x value is equal to 1 upon 2023, you won't get any idea how you will proceed to it. You will get something like this: 2023 upon same term. This is what you will get if you put values of x directly in this fx. Now we need to simplify it in such a way that either maybe the sums of the continuous terms get cancelled out or something like that should come. Let us see. So I can write fx as 2 to the power 2x. I can bring this power to inside and make it I can consider it like this as well, right? Because power to the power gets multiplied, so when it comes back inside it will become 2 to the power 2x, and here also it will become same. Now 2 to the power 2 is 4. We get 4 to the power x upon 4 to the power x plus 2. Now substitute x by 1 minus x. Let us see what comes. So making it 1 minus x, same will come here as well. It will become 4 to the power 1 minus x upon 4 to the power 1 minus x plus 2. Now if you multiply by 4 to the power x in both denominator and numerator of this term, this fx f1 minus x, what we will get? I'm doing it directly here. 4 to the power x upon 4 to the power x. So when it will get multiplied with this, in multiplication powers get added. So 1 minus x plus 1 x will cancel out. We will be left with 4 to the power 1. What will be here? When it will come here, same will come 4 plus here will be 2 into 4 to the power x. Now take 2 common in both numerator and denominator and cancel out. We will get 2 upon 2 plus 4 to the power x. Now if you see one thing here, this is fx, this is simplified f1 minus x. In denominator if you see, it is 4 to the power x plus 2. Here also if you see 4 to the power 2 x plus 2. Now let us add these two terms. What we will get? F of x plus f of 1 minus x. Fx is 4 to the power x upon 4 to the power x plus 2. f1 minus x is 2 plus 4 to the power x plus 2. Both the denominators are same, so we can take LCM. 4 to the power x plus 2, and in numerator as well we will get the same. Both numerator and denominator are same, which will cancel out and we will get 1. So here what we see, fx plus f1 minus x is always 1. So this thing we need to use in this sum. How we can use that is, I'll show you. So we have got this sum as 1. Let me put that here. F of x plus f of 1 minus x is equal to 1. This is what we have got by simplifying this. Then now we need to write these terms in this way. So let us consider x as 1. X is 1 by 2023. What will be f1 minus x? f1 minus 1 upon 2023, which will be f2022 upon 2033. What is that? That is this last term. So sum of this plus this, fx plus f1 minus x. f1 plus f2023 upon 2022 upon 2023 is 1. So how we can express this? Sum of terms equidistant from starting and end is 1. So what will be the term here? Here the term would have been f of 2021 upon 2023, right? So this and this, f2 plus f2 minus 1 upon 2023 is 1. And now so we can see that first and last 1, second and second last 1. Now how many times this will repeat? So this is starting from 1 and going to 2022. Now terms will become half of it. Right now terms are 2022, then terms will become half of it, that is 2022 upon 2 is 1011. So this 1 will be written 1011 times, which will become 1011. This is our final answer. So sum of these terms was asked and sum is 1011. That is the sum of these functions. So I hope it is clear. So if we get any complicated functions, then what we should always do, we should always consider simplifying the terms. If we could cancel out some terms, or next question we will see. This was question number 5, so next will be question number 6. What is next question? Fx is given, then we need to find expression satisfying this f. Okay, fx is fx is given as x cube minus 2x f dash x minus x square f dash 1 plus x f dash 2 plus x f dash double dash 2 minus f triple dash 3 plus f double dash 2 minus f triple dash 3. This is fx in terms of x and some of its derivative. Now few expressions are given like 3f1 plus f2 is equal to 3. We need to select which of these options is correct. So we need to find fx in terms of x. Now how we can do that? So these are the constant terms, f dash 1, f double dash 2 and f dash 3. These are constant terms. These will always remain constant. So if we can write answer, let us consider f dash 1 is equal to a, because this way you might get confused that f is on this side as well, this side as well, but these are constant terms. We just need to find these terms to find the fx. And let's say f double dash 2 is equal to b and f triple dash 3 is equal to c. Write this in fx. We get fx is equal to x cube minus what was f dash 1, a. So we get a x square plus bx minus c. This is our fx in terms of three constants, and we have already been provided with three derivatives in terms of this ABC. So if we can get three equations, then we can find three variables. Now let us differentiate fx. What is general derivative? General derivative is d upon dx, x to the power n is equal to n x to the power n minus 1, and derivative of a constant is always 0. Remember, this is not same, you can consider c dash. It is any constant, it could be anything. So derivative of constant is 0. Let us differentiate fx. We get f dash x is equal to x to the power 3. What is derivative of x to the power 3? 3 into x to the power 3 minus 1, which will become 3x square. Same here, x to so a is constant, it will come outside of derivative. What is derivative of x square? 2 into x to the power 2 minus 1, that is 2x. So we get minus 2ax plus bx. What is derivative of x? X power is 1, so we will get 1 into x to the power 1 minus 1. 1 minus 1 is 0, or anything to the power 0 is 1. So we will get b minus, this is a constant, so derivative of constant is 0. So we get fx is equal to 3x square minus 2ax plus b. We have been provided with f dash 1. Put x is equal to 1. F dash 1 is equal to, no, let it be. First find the other derivative. Differentiate f dash x, we will get f double dash x. So 3 will come outside. Derivative of x square is 2x. So 3 into 2x will become 6x minus 2a will come outside, derivative of x is 1, so we will get minus 2a plus derivative of b is 0. Now again differentiate this, we will get f derivative of x is 1, so 6 minus constant 0, so we get 6. And so f third derivative is a constant number irrespective of whatever value of x is. Here if we can put x is equal to 3, we will get f dash 3 is equal to 6, which is equal to c here. So we have got value of c. Now these two equations are also there. Okay, this can be removed. This can also be removed. We have got c is equal to 6. We will use that. We have got f dash 3 is equal to c is equal to 6. Now these two equations are there. Put 1 x is equal to 1 in this, we get f dash 1 is equal to 3 minus 2a plus b is equal to a. Put 2 here, f double dash 2 is equal to 6 to the 12 minus 2a is equal to b. These are the two equations we have got. Now b is equal to 12 minus 2a. Put this value of b here in equation 1, then we will get this equation in form of a only. What we will get? 3 minus 2a plus, what was b here? B is 12 minus 2a. 12 minus 2a is equal to a. Minus 2 become minus 4, so minus 4a. Bringing it to this side, we will get 12 plus 3 is equal to 15 is equal to 5a, which gives us a is equal to 3. Put this value of a here. 12 minus 2 into 3, 6. 12 minus 6 will become 6. That will give us b is equal to 6. So we have got three parameters. C is equal to 6, C is equal to 6, B is equal to 6, A is equal to 3. These are the values we will use in fx. We don't need anything else now. So we have got fx is equal to x cube minus, what was f dash 1? F dash 1 was a is 3. So we have got 3x square plus f dash 2. What was f dash 2? b. So this is 6x minus c is 6. Now what has been asked? So these options are relating f1, f2, f3. Let us find f1, f2, f3 from here. Put x is equal to 1 in fx. We will get f1 is equal to 1 to the power 3 is 1 minus 3 into 1 square plus 6 into 1 minus 6. We get 6 and 6 will cancel out. 1 minus 3 is minus 2. F of 2 is 2. 2 to the power cube is 2 into 2 into 2, 8 minus 3 into 4, 12 plus 6 to the 12 minus 6. 12 and 12 will cancel out. 8 minus 6 will become 2. F of 3. 3 to the power 3. 3 into 3 into 3. 3 3s are 9, 9 3s are 27. So 27 minus, this is also 3 into 9, that will also be 27, plus 6 into 3 will be 18, minus 6. So 27 will cancel out, 18 minus 6 will be 12. So these three terms we have got minus 2, 2 and 12. Now what is first option? First option is 3 into f1 plus f2. 3f1 plus f2, let it get it, just 3f1 plus f2 is equal to f3. This is first option. 3 into f1, what is f1? Minus 2. So 3 into minus 2 will become minus 6 plus f2. f2 is 2 barabar f3. f3 is 12. Is this satisfying? This side is minus 4 and this side is 12. So this option is not correct. So first options won't be there. Second option is f3 minus f2 is equal to f1. What is f3? So 12 minus f2 is 2 is equal to f1 minus 2. Here we will get 10. 10 cannot be equal to minus 2. So second option is also incorrect. Third option, 2f of 0 minus f1 plus f3 is equal to f of 2. We haven't found the f0, so what will be f0? Put 0 0 0 minus 6, so f0 will be minus 6. Now what it says, 2 into f0, 2 into minus 6 will be minus 12 minus f1. f1 is minus 2, so minus minus will become plus 2 plus f3. f3 is 12 is equal to f2. f2 is 2. So here you see these terms are equal and opposite. This will cancel out, only 2 will be left. 2 is equal to 2. So this option number 3 is correct. We will also verify option number 4. In exam we don't need to verify if you have got the answer. We don't need to verify the other options. Option number 4 is f1 plus f2 plus f3 is equal to f of 0. f1 minus 2 plus 2 plus 12. 2 and 2 will cancel out. It will be left with 12 is equal to f0. f0 is minus 6. This is not correct. So third option is the correct answer here. We will see next question. This was question number 6 of this series. Now we will see question number 7. Question number 7 is, it is asking the number of integers greater than 7000 that can be formed using the digits without repetition. What digits we have? 3, 5, 6, 7, 8. 3, 5, 6, 7, 8. And a number 7000. So we need to find all possible numbers who are greater than 7000 that can be found using these digits without repetition. No word will be repeat, only one word can be used once only. Now let us see this question. This is a probability question, NCR NPR, permutation and combinations question. Sorry. So here the first number is 7, other terms are 0. So if we consider a 4-digit number, so there are 5 words and we need to find numbers greater than 7000, which is a 4-digit number. So there are 2 possibilities. The number can be a 4-digit number and the number can also be a 5-digit number, because we have total terms 5. Now let us first see for the all possible numbers, all possible 4-digit numbers greater than 7. So if you want it to be greater than 7, then first term, this term should be equal to or greater than 7. 3, 5, 6. We can't keep 3, 5, 6 here, because if we keep here, then this whatever number we get using all the terms will always be less than 7000. So first term can be 7 or 8. Only 2 possibilities are there. Okay. So let us say one of these will come, then we will be left with 4 terms. This place can be selected from 4 terms. So we have 4 possibilities here, 4 options here. This will be 3, this will be 2. So this will be multiple of all these. First number can be selected in 2 ways. This can be, then remaining terms will be 4, 3, 2. We will be left with 1 number. So you might be thinking, what if the first term is 7? So if the first term is 8, then it will always be greater than this. Now what to consider the case when first term is 7? This is 7. When it can be less than 700? Only when all 3 terms are 0. Then it will become greater than, then it will become equal to 7000. So that case won't be considered. But that cannot happen here because we don't have the zeros here. Now you consider any number here, it will always be greater than 7000. So these are all the possible 4-digit number. What is the number? 4 3 12, 12 2 is 24, 24 into 2 is 48. These are all the 4-digit possible numbers. Now let us consider 5-digit numbers. So we have 5 different numbers and we need to form a 5-digit number. What are the ways? 5 into 4 into 3 into 2 into 1. What is this? 20, 23 is 60, 60 into the 120. What then total will be 120 plus 48, which is 168. These are all the possible ways we can form a number greater than 7000, and this is option number 2. This was question number 7. Then we will see one more question. That will be last question for today. 8th question. What is that? Question number 8. We have been given system of equations has infinitely many solutions. Then the order pairs is equal to. What are the 3 equations? Okay, is this plus 3z 3 4x plus 3y minus 4z equal to 4. 8x plus 4y minus lambda z equal to, though these are the 2 parameters, it expects us to find the values of theta and mu. It is given that it has infinite many solutions. When we have infinite many solutions, when we have this form, we get 0 on this both the sides, because in that case we will get 0 by 0 form, which will have infinite many solutions, which can have any number of solutions. So here we need to find any of the variable in form, any of the variables. What are variables? X, y, z. Any of these parameters in form of lambda and mu. Then we can make that variable is equal to in 0 by 0 form. So we will eliminate the other two parameters from these three equations. Equation number 1, 2, 3. Here we see this is x and this is 4x. If we can multiply it by 4 and subtract this from that, then we will get also x will get removed. We will be left with y and z. So do 4 times equation 1 minus equation 2. 4x minus 4x will be 0. 4 to the 8. 8 minus 3 will be 5y. 4 is a 12. 12 plus 4 will be 16z is equal to 4 is a 12 minus 4 will be 8. 5y plus 16z is equal to 8. This is equation number 4. Now here we have 4x, here we have 8x. Multiply this equation by 2 and subtract that from this. So 2 into equation 2 minus equation 3. You will get 0. 3 to the 6 minus 4y gave to 2y minus 8z. Minus minus will become, which will become lambda z is equal to 8 minus 9 plus mu. This gives us 2y. Here from this equation, we will write y in terms of z. What we will get 8 minus 16z upon 5. Right? Plus lambda z minus 1 minus mu. We will simplify this thing. What we will get, so we have this equation in terms of z and mu and lambda. So take 5 as LCM and get this 2 inside. We will get 16. 8 into 2 will become 16 minus 16 into 2 will become 32 z. Taking 5 LCM, we will get 5 into 8 minus 40z plus 5 lambda z is equal to, we will have 5 LCM here. When we bring that to this side, we will get minus 5 mu. Simplify, so minus 32 minus 40z will become minus 72z plus 5 lambda z is equal to, bring this 16 to this side, it will go minus 16 minus 5 minus 21 minus 5 mu. Take z common here. So this is the z. Further simplifying it, we get z is equal to This is what we have got Z, and it is saying that it has infinite many solutions. When that can happen when Z is 0 by 0, so both are 0. So making them equal to 0, making the numerator equal to 0, we get minus 21 minus 5 mu is equal to 0. From here we will get mu is equal to minus 21 by 5. Making the denominator 0, we will get minus 72 plus 5, lambda is equal to 0. From here we will get lambda is equal to 72 by 5. So we have got both the values, lambda and mu. So our ordered pair, lambda mu or lambda mu, lambda 72 upon 5 comma minus 21 upon 5. Which option is this? 72 upon 5 minus 21 upon 5 is option number 3. Sure. Option number 3 was correct here. So we have solved 4 more questions today. That is all for today. In the next session we will see 4 more questions and we will complete this entire 2023 paper in all the sessions. So that's all for today. Thank you.